So today we're going to be comparing the simple interest formula, which you guys have already shown that you're very confident with, and showing how it actually applies to the real world, how banks actually use the simple interest formula. So you see at the top of the page it says for each example we're going to use a starting balance of $3,000. We already know that's going to be the principal, that's where we start. And the bank we have chosen will provide us with a 4% annual interest rate, which is a pretty good rate for what you can get today, fairly realistic. And it says that we're planning to save our money for 5 years. So number one, it's just a simple interest problem. This is what you guys have been doing before. Using the simple interest formula, how much money will we have after 5 years? Now the reason I have a number line set up for us is because we really want to think about this as we're starting here today, and our money is going to grow and grow and grow until the end of 5 years we're going to take it out. Okay, so again, here's today, right, year zero, but I'm going to take the money out at year 5. And if I'm talking about a simple interest formula, well, that just means that interest is equal to the principal times the rate times the time. If I'm talking about simple interest, there's not going to be anything out of the ordinary with this. What I'm trying to figure out is the interest that I'm earning. I know the principal is 3,000. You can fill in the rest of these numbers without me just as well as I could. This is what you already know. I do have to make sure that the time is in years, and yes, it is 5 entire years, so I would use a 5. Now, your calculator will tell you that the interest then would be $600. Now, at which point I'm hoping you guys are realizing that $600 doesn't make a whole lot of sense here, right? Because it says how much money will we have after 5 years. And there's no way I'm going to only have $6,000, right? Because remember, what I figured out, if I'm going to use this equation, it says interest. And remember, interest is not how much money you have. Interest is the amount of money that you earned. So if I earned $600, I had $3,000, I gain $600 in interest. So today, after 5 years, I have $3,600. Now also don't forget there's an easier way to solve this problem. It's going to help us out in the rest of the paper especially. So I want to make sure that you have this one too. Okay, really the one that we did is helpful, but there's a shorter way, right? I'm still going to use the same formula. But remember, what I really care about isn't so much the interest. What I care about is like the final balance, right? How much money is in my account at the end. So if I'm trying to find out the balance instead, and I'm using the principal and the rate and the time, the only difference with this equation, still going to start with $3,000, but my rate, how quickly is my money growing, I want to know if I still have 100% of what I put in, plus 4% interest that they're giving me. Really what I care about is what's 104% of $3,000, right? Instead of doing the 4% interest and adding it to my total at the end, I can just start off and say, well, this would be 1.04. It's an increase problem. I'm increasing my bank account by 4% over 5 years. So in that case, your calculator will tell you without any doubt, if you do 3,000 times 1.04 times 5, you get the answer right away. Okay, this approach, this equation is the one we're going to want to use for the rest of the page because that's how the real banks take care of your interest. Now looking at number 2, the first 2 words say compounded annually. Well, annually means once per year, right? An annual event happens once a year, so annually. Compounded means it's not going to be simple anymore. It's going to be a little bit more complicated. And this is what the banks actually do. because the interest rate is given annually, the bank's going to deposit the interest you have earned at the end of each year. Okay, so if you keep your money in the bank for 1 year, they're going to calculate that interest and put it into your account. So that means that each year your starting balance is going to increase because they're going to take the interest that you earned and put it in your account. So then the next year, when your balance is a little bit higher, you're going to earn interest on that full amount. Okay, which might sound a little bit more complicated, but we'll do this example together, kind of show you what I mean here. It says the interest you earn will be reinvested for the next year. Calculate the balance at the end of each year for the first 5 years. Okay, because we still have this number line here, right? We're going to start at 0 years. I'm going to end way out here at 5 years. But if it's going to be compounded annually, what they're going to say is, okay, at the end of 1 year, how much money would you have? They're going to put that back in the bank and invest it until the second year. They're going to take that money, put it into the third year, put that money into the fourth year. Now, I really didn't space out my number line very well, but here would be 0 years, here would be 1 year, and then we also need to calculate it until we get to the end of our terms, okay? I gave you a little table to help organize your work as you go here. The starting balance, remember, we're still using the same numbers as the first problem. We're going to start with $3,000, okay? Now again, I'm dealing with the first year here, so principal times rate times time, I have $3,000. Don't forget the rate that we care about now is 104%, because it's going to be a 4% increase of what it was before. And the time. Overall, I'm going to leave it in the account for 5 years, but if I'm doing this 1 year at a time, the time that I have to use is 1. Because this next box over here, the ending balance, after year 1, how much money do you have? If I invest $3,000 for 1 year, at the end of that, my calculator is going to tell me I have, come on, you should have your calculator out now. This is something you should be able to do here, right? I'm not going to help you through this whole paper. Ending balance has got to be 3,120. Okay. So now what I meant for year 2 was they're going to take that interest. You earned $120. They're going to put that into your bank account so that when you start the second year, you now have $3,120 in your account. So whenever we go to the equation, it's not going to be a $3,000 principal anymore. You have more money than that. It's going to be $3,120 times a 4% increase. And again, your time is going to be 1 year. Because in your second year, you're going to leave it in the bank for 1 more year. What I want to know is after the second year, how much money do you have now? Again, your calculator will tell you this. Okay, you're going to start getting some decimals here. How many dollars, how many cents would you have at the end of year 2? If you leave it in the bank 1 more year, what do you have now? Now, don't forget this is money, $3,244.80. Now, that's the last one I'll do with you, but remember, that means when you start year 3, now your starting balance has changed. Again, it's going to be $3,244.80. Okay, so I'm about to end the video here, but in order to get full points for the project, you've got the rest of these boxes to fill in. What do you have at the end of year 3, end of year 4, end of year 5? And then the last question on the page, how much more money do you earn in 5 years when it's compounded annually, right? When the bank gives you this compounded interest, how much more money do you make than you would have in number 1 when it was just simple interest?